All right, so just some general information about our hyperbolas here. I already did an example in a previous video that showed you how to graph, but this is kind of the general information when we're putting it in this chart form or just to have and kind of be able to work it all out. So the center of our hyperbola is just like center of an ellipse. I'm actually going to sneak in our standard forms over here. So our first one is when our parabola opens left and right here. So that would be x minus h squared, y minus k squared over a squared is always first in our hyperbola. And we'll see, we know that this would be horizontal because x is the first variable, is the positive fraction. For the hyperbolas that open up and down, the thing that's going to be swapped is y is going to be that first numerator. But notice a is still on the bottom. And then we're subtracting that x fraction. So these look similar to ellipse equations, just that negative in the middle, we're subtracting. So the center is going to be hk from our equation. Remember, h is always with the x. All right, our vertices, we're still taking a, whatever the a value is, and adding it. Now it depends if we're adding it to h or k on which way the hyperbola opens. So if the hyperbola opens left and right, our first horizontal one, then we're changing the h value, right? The horizontal value. And it'll be h plus or minus ak. The only way this changes for our vertical hyperbola is instead of changing right vertically, we're going up and down to get those vertices. So now vertical k plus or minus our a value. The foci are pretty much identical to what we do for the vertices, but now we're going from the center pretty much into our curve. So we're going to add c to either the horizontal variable or our vertical variable. All right, the asymptotes, that's where B comes into play, right? So we'd have A going out to our vertices. B would create what we call the conjugate axis. And we would use B to get the slope of the asymptotes. So my rectangle's a little bit off there. But if you saw our first graphing example, then hopefully you kind of got a hang of that. So the difference for our equations is going to be which axis, which direction the conjugate axis goes. So in this first example, B is our vertical distance, and then A is the horizontal distance. So for this one, our asymptotes would be the slope, at least, plus or minus B over A. Now you can use any form of a line, but for the general form, I'm going to use point slope. And we know a point on or at both of the asymptotes would be the center of our hyperbola. So that would be y minus k and x minus h. The only thing that changes for our vertical hyperbola is that we're going up a for the slope, since the vertex is vertical, and then over b. So plus or minus a over b, x minus h. All right, and that last thing to remember in order to actually find the foci is the relationship between A, B, and C. For hyperbolas, C is the largest distance, so it's going to be A squared plus B squared equals C squared. And you guys can do some looking into maybe how those relationships are formed. There's so many things out there you can Google and check out about hyperbolas. We'll be just seeing a couple of them in the next few days.